Specific latent heat is a concept that helps explain the energy required for a substance to change from one state of matter to another without a change in temperature. When a substance undergoes a change of state, such as from solid to liquid, melting, or liquid to gas, boiling, it requires energy to overcome the forces holding its particles in their current state. This energy is necessary to facilitate the transition between states, even though the temperature of the substance does not increase during the process. The specific latent heat of a substance is defined as the amount of energy needed to change the state of 1 kilogram of the substance without changing its temperature. This energy is used entirely to break the intermolecular bonds between the particles in the substance, rather than increasing the kinetic energy of the particles, which is why the temperature remains constant during the change of state. There are two types of specific latent heat: the specific latent heat of fusion and the specific latent heat of vaporization. The specific latent heat of fusion refers to the energy required to change a substance from a solid to a liquid, or vice versa, at its melting point. On the other hand, the specific latent heat of vaporization is the energy needed to change a substance from a liquid to a gas, or from a gas to a liquid, at its boiling point. The formula to calculate the specific latent heat, L, is given by the equation E equals mL. In this equation, E represents the total energy required for the change of state, m is the mass of the substance, and L is the specific latent heat. This formula shows that the total energy needed to change the state of a substance is directly proportional to its mass and the specific latent heat value of the substance. For example, if you want to calculate the amount of energy needed to melt 2 kilograms of ice at 0 degrees Celsius, you would use the specific latent heat of fusion for water, which is approximately 334,000 joules per kilogram. By multiplying this value by the mass of the ice, you can determine the total energy required to change the ice into water. Specific latent heat is crucial in understanding the energy dynamics involved in changes of state. It explains why, during phase transitions like melting or boiling, energy input is necessary without a corresponding increase in temperature, and it provides a way to quantify the energy involved in these processes using the relationship between energy, mass, and specific latent heat.